Hello, this is Marian, and today I'm going to walk you through how I access my data on the Texas Advanced Computing Center. So what I do is that I'm going to share my screen. So what I do is I use this application called Terminal. You can find it in your apps if you have a MacBook, or if you have a window, you can always use X11 and different type of terminal. So I use terminal, so I already have like Windows open, so I'm gonna go new Windows so I can walk you through it. So what I do is I will enter my SSH key here in order to be redirected to the computer straightforward. So give me a minute to find my coordinate here. So basically, I'll go to my thesis work and get the information that I saved here. Now my computer is crashing. In my terminal code, basically, I log in using SSH-Y, and then this is my password to log in. So definitely I have like different version of them, and I like using this one, the red one here. So I'm just gonna copy this and paste that in my terminal here. Try to drag it down a little bit. Okay, all right. Here, and I'm just gonna click enter. And directly it connects me to the computer. And in order for me to get this access, I had to go to the Texas Advanced Computing Center Access Program website, and I had to create an account and request access. And once my account was approved through my advisor work in progress, I was able to get my login and create my own password and two-factor authentication. So right now I'm gonna have to enter my password. Then it will lead me to the two-factor authentication that I'm going to do through my phone. It uses Duo Mobile. So to my password. Okay. And now I'm gonna have to go to my Duo on my phone to find the code for the Texas Advanced Computing Center. And I'm gonna enter that code in now. And normally, if everything is right, you will be able to see, like here, you can see that I have access to the supercomputer. So that's what my interface look like. I have this beautiful view. So it shows me all the folders that are in here and pretty much what I have access to in my own folder. And the way I like to do it is to go easily to all my documents that I have stored in a specific directory. I'm just gonna copy my directory path and then log in. But before that, I didn't have all the packages required to plot and access the data on my computer. So I had to download all of them in an environment. So I just need to log back into my content environment. And once I'm in my environment, I can, so I'll have to load my Python. Then I'm going to activating my environment to make sure anything that I do is inside my environment. So I will activate this, Then I will activate my environment that I just called my env, which is my environment. And once I'm in my environment where all my packages are, I will enter this path from my directory to all where I have all my files. So basically, I will have to delete a little bit of this because this is for a specific so this happens often, and when I run through this issue, I just have to use Control Z to stop whatever operation I accidentally started. And basically, this is like plotting something that I didn't want to plot. So I will just do this again, and then I can do ls to see exactly all my files. So those are all the files I've been working on, and show me all my files here. So those are all the fields that I have plot of my different merging and also different timestamp of the whole simulation. So this is how I access my space on the Texas Advanced Computing Center. And from there, I'm able to do all my work and put all my data. So unfortunately, on here, I can't open any of the files. If I'd like to open a file, I'll have to open a new terminal window. And on that terminal window, I will download the file. So usually, let me copy and paste the path to do that. So I will just use this path here. This path here, for example. And if I run this, it would just ask me to put in my password again, which I would do. Okay, I was in the wrong password. So my password again, my password this time. Then I go back to my Duo Mobile. I enter the key that is available there. 789, oops, 298 actually. And when it works like this, I have my picture downloaded from the path that I pasted here. Once my picture downloads, it goes to, and just move it so I can see where it's going. So I didn't define where exactly I wanted it to go. But usually let me paste like another one that I use all the time. So usually I would use this path instead. And this one, I have the same thing. However, from this part here, I tell my terminal when it downloads my file where to bring my file. So if I do this right now, it's gonna download all the files that have an index PNG and send all those files to the merging plot document that is on my desktop. So I'm not gonna do it right now because I already have all of those files. So this is just to show how I get the data of the supercomputer and like into my local machine. And this is pretty much all the files that I have on the supercomputer. So to access the field that were already here from the simulation, I'll have to enter another path that like lead me straight to it. So all my fields are on the scratch part of my document. which basically I will have to PWI to my directory here. And in order to find where my thing are, I would just, they're in my environment. So I might want to ls from here to, this is what I have. So, okay. Just a second. This is the wrong kind. So basically, I have to copy the same thing. Let me do that again. So I have to pwd, which brings me to my working directory. And I'd like to open this directory here. So I go to this directory. Okay, it's under the directory. If I open it, okay. I have to pwd that actually. So once I do that, I need to, oh, how do I go to my, where are my files? I did write that down somewhere. Where was it? Where is it? I don't remember. Oh my God.
What was, oh, the masala sauce that she bought, yes. I know what you're talking about.
Oh boy, change the directories. Terminal. Oh, I see the, okay, I see this.
Yeah, you should take that and throw some peas in there too. Yeah. But then it's good shot that comes with the paper too.
Okay, so in order for me to access all my simulation files that have been saved on my space on the supercomputer, also all those files were sent by my professor. So I haven't been here in a long time, but usually like the file get deleted over time. So if you don't use them often, you just like lose them as you go. So for example, those are the files that I have left, and because I haven't been using them in like months because I was like done with the work. But the way to get to it is I need to access the directory where those files are saved. So if you remember the first path that I copied and pasted here, from CD Scratch 10,806 MTB 5862 Python. This is where all my files, so all my plots, my pictures, my code are stored. And the simulation file, they're stored in my Scratch folder. So inside my Scratch folder, I have two. I have like inside Scratch, I have my folder here, and I have another folder with my name, and that's where I have my field data are in May 27 too. And so my simulation data are in May 27 too, and my Python, all the pinky file here in Python. So in order for me to get to that, I just have to use cd, which in current directory. So I'm telling my terminal space to find my current directory and telling it which directory I want. Once I do that, it brings me to that directory. And I just have to use the ls that gives me everything that is inside that directory. So those are all the files that I have now because most of them were deleted because I haven't been using them in a while. So this is pretty much how you will connect to a supercomputer like the Texas Advanced Computation Center one and use your data to plot. So if I go back to my initial directory with all my Python code and files here, I will have, let me go back. So here, once I have everything, again, I can ls, you see, same thing, I get my thing. So in black here, those are my Python codes, and everything in pics are all the pictures, the plot that I run. So if I decide to open one of my Python code, I would just have to VI it and copy, paste that here. And it's just going to give me the code. So pretty much I can run through the code. I can edit like anything I want in here containing. So right now I cannot edit anything. In order for me to do that, I just have to click on I, and I can move across the code and change anything that I want. And I use this specifically to plot my B field. So let's say now I exit. So I just escape and I use colon, WQ, and exclamation, and then it saves everything. And in order to plot the output from my code, I will just do Python and my same code here, my code. So Python in this terminal here in the context, it just means plotted. So I'll wait for my plot and it's just gonna appear because I'm also connected to Explorer, which has the graphic display. So terminal normally itself doesn't have a graphic display. So you might want to connect also to add an extension. I'm not really sure how this will go if you don't have a Mac, but with a MacBook, you can just download X11, and X11 has the graphical display that you can use. So when all is done, I can just see my plot. So this is currently printing the density here and each row X, and then it just shows me. So this is the crop version that I use for most of my work, and it just happened like this. And when I close it, you also close the action here. And if I decide to plot something else, so I have different sort of fields here. Those are the same code, add to version because we're running some issues. And for example, this one is for specifically row X. And this one is for me to get the magnitude of the field. So we can look at the code as well as also see the output. And the movie new .py is my interactive code. So I use this code to stack all my field files after I extract them from the simulation, and it allowed me to create a movie out of like all of it. So I can show the movie a little bit after this. So if I go through this and then I run through it, so basically your cursor wouldn't work here. So you have to use all the direction from your keyboard. So basically you enter this and this is my Python code, basically. So it basically has everything that I need. If I want to print out a specific field, I will just put the specifics in here. And for example, May 2072, this is where my file is stored. I will show you my folder that has all my simulation file. And this here, if I run it, it will print my magnitude of the magnetic field for both the simulation file number 138 and the simulation file number 395. So we can exit because we haven't made any change. We can just exit with this one and I can Python it. So if I Python this, it would just give me the output of my code. So why we call it cut? Because it's basically just telling the code, hey, go at this specific location in the simulation field and give me the magnitude of the magnetic field at that time. So as it'll take a little bit of time to run. Not so sure why it's taking so long, but normally it would just happen with you a few minutes and gives you the output. So here, as I said, it gives me the output of like simulation number 395 and simulation number 138. So the low blue one will be the 138 and the 295 because this is me following the amplification of the magnetic field, and this is pretty much how I get all my data. And then for the movie, I'm just gonna do the same and tell. So if we open it, you could see I'm not gonna print a movie right now because it takes a really long time to go through. But if I come here and look at my file here, I basically tell the code from where to begin and where to end. So basically, this one will give me a movie from 245 to 278. So all the field, the simulation field that are from number 245 to number 270 will be stacked together in order to give me a movie. So right now, all those files have been deleted from my account, so I wouldn't be able to print anything using this, but I got a lot of my movies I can show you from doing that. And then everything is stored. I can edit my code directly on terminal and also paste anything that I'd like to change. So this is pretty much it for how I access my data and like what my interface look like, how I log in and stuff. So now I could show you how to download the data. I can also show you how I created my account. So I go to the access tag here. It's basically this one, user portal. Come here, put in my information, and then how to create, I log in my account. So this shows me, for example, what research am I part of, who is the principal investigator. In this case, this is my advisor, and what exactly I have access to. So for all my work, I've been using the Stampede3. And I also have access to other type of like data that I'm not currently using. So right now we're working on this specific project and I am just like a co-investigator with my professor who's the main owner. And I was able to gain access to this data through her because she had to request access for me through her research. I'm assuming if you're studying this on your own, you probably will have to send in a project and ask for a request to have access to the data. But she's been part of this project for a very, very long time. So she kind of have access to it. So if I go to my drive and then I show you, okay, this is the wrong drive. So if I go to my drive here and I show you my from my student project here, I could show you I have all my files here. So the movies, I don't know why I only have my plot. So my plot looked like this after I've done all of the things that I explained. And also I have on my picture. So this is a movie, for example, that I made by stacking all the data together. And it showed me what happens as my merging is happening. So as those two tiny MDVs come together, this just shows me how they merge and stuff. So it gives you like a more clearer perspective on how to analyze. And those like are a bunch of like individual movies that I made for different quantities. But like initially when I started my it pretty much like looked like this. My field plot looked like that. And I had like to plot over different intervals to see anything. Those are my cuts here I showed you. And merging plots here, different, so many things going on. Like this is like my plot of the field. You can see it moving around and so on. So this is pretty much it for how to access the data and what you can get from it. So I hope this could help somebody or makes add more context in my work, because I know it's like really hard to visualize those things from explaining it, talking about it, to actually showing it the work.